Hey everybody, today we are going to divide monomials. So before we start with the notes here, I want you to look over here to the side. If you were going to take x to the fifth divided by x to the third, think about what that means. X to the fifth means you have 5 x's you're multiplying together. And x to the third means you have 3 x's you're multiplying together. Well, think about if you take an x and divide it by itself, you get 1. So 3 of these are going to cancel out. And you're left with 2 x's, which would be x squared. So the shortcut here, since you know that they're going to cancel out, is you're going to subtract the exponents. So to divide monomials, use the quotient rule, which the base stays the same, and you subtract the exponents. And remember, you can only use this rule if they have the same base. So if they have different bases, then you can't simplify it. So let's go through and look at some of these examples. Make sure you follow along. You can pause the video at any time. So for number 1, again, they have the same base. You're dividing, so the base stays the same. You're going to subtract the exponents. 5 minus 3 is x squared. 2, they have the same base. The base stays the same. 12 minus 2 would be k to the 10th. Now 3 is a little different. When I use my quotient rule, the base stays the same, and then I'm going to subtract the exponents. I get m to the 0. Now this is not completely finished. If you look out here to the side, m to the third would mean I'm multiplying 3 m's together. Same thing in the denominator. So basically what's happening here is when you, oops, I'll put that back there. When these cancel out, remember m divided by m is 1. M divided by m is 1. Same thing here. And then 1 times 1 times 1 is just 1. So anytime you come up with an exponent of 0, it's equal to 1. Because basically what that's telling you is they have all canceled out. And you're left with the number 1. 4, same idea here. You cannot multiply. Cannot use your product rule because A and B are different bases. So you're going to have to look this way and use your quotient rule. So for the A's, the base stays the same. Subtract your exponents. 6 minus 2 is 4. For the B's, the base stays the same. 4 minus 3 is 1. Now, you can put that 1 up there, but we don't need it because it's assumed. So you're not usually going to see that. 5, again, you can't multiply them because they have different bases. So we're going to look and divide. The base stays the same. Subtract your exponents. Same thing for the Q's. The base stays the same. Subtract your exponents. 6, same idea. You have x's, y's, and z's. You can't multiply them, but you can divide them if they have the same base. So the base stays the same. 20 minus 5 would be x to the 15th. The y's, y to the 9th divided by y to the 9th would be y to the 0. And remember, that is 1. And when you times with a 1, you don't need it. Z to the 2nd divided by z to the 1st would be z to the 1st. So to simplify this, you would get x to the 15th times z. Again, when you come up with an exponent of 0, it's equal to 1. Now, sometimes you're going to have coefficients. Remember, coefficients are the numbers in the front that are being multiplied by the variables. So if you have coefficients, remember those are numbers. Those are not exponents, so you don't want to use exponent rules on them. So you're going to divide the coefficients and then use your exponent rule, your quotient rule on the exponents here. So for number 7, the 6 and the 2 are just numbers. So 6 divided by 2 is 3. And then x to the 4th divided by x to the 3rd would be x to the 1st. For 8, again, 14 and 7 are the coefficients. Divide those. 14 divided by 7 is 2. R to the 2nd divided by r to the 1st would be r to the 1st. And s to the 2nd divided by s to the 1st. Remember, subtract your exponents would be s to the 1st. 9, divide your coefficients. Negative 36 divided by 4 is negative 9. Now use your exponent rule. C to the 2nd divided by c to the 2nd is c to the 0, which is 1. And when you multiply with 1, it doesn't do anything, so we're done with that. D to the 5th divided by d to the 3rd. Subtract your exponents is d to the 2nd. 10, again, divide your coefficients. Negative 15 divided by negative 3 is 5. X to the 6th divided by x to the 5th. The base stays the same. Subtract your exponents. That would be x to the 1st. y to the 5th divided by y to the 3rd. Subtract your exponents would be y to the 2nd. And then that z, there are no other z's, so it can't change. It's just going to stay put there. Also, it's a big deal whether a variable or number is in the numerator or denominator, so be careful where you put them. For example, number 11, it's 4 divided by 8. 4/8 is not the same as 8/4, because a lot of kids come up with the answer 2 here. Think about 4/8 as just a fraction. Reduce it. They can both divide by 4, so you get 1/2. N to the 5th divided by n to the 1st, subtract your exponents, you get n to the 4th. Now, a couple things. You don't need that times 1, so you could just write this n to the 4th over 2, but you could also write it 1/2 n to the 4th. Those are the same thing, so either way is fine. Last one here, number 12. Again, 36 divided by 4. Just think of that as a fraction and reduce it. They both divide by 9, but if you think bigger, they both divide by 18. So you want to completely reduce them. So if I divide by 18, that's 2, and that's 3. So I got a 2 on top, 3 on bottom. M to the 9th divided by m to the 3rd. Subtract your exponents. The base stays the same. You get m to the 6th. Because remember, think about that. You had 9 m's on top and 3 m's on bottom. So 3 of them are going to cancel out to 1. So you're left with 6 on top. N to the 5th divided by n to the 2nd. Subtract your exponents would be n to the 3rd. So again, you could write this with the 2/3 out front. Or you can leave it with the 2 in the numerator and the 3 in the denominator. They mean the same thing. Okay, now we are going to do the odds. And then you guys can go back and try the even. So stay with me on the odds here. So for 13, the directions say simplify each expression completely. Now, we have to use our order of operations here. I cannot simplify the 3 and the 27 because that 3 is in parentheses with an exponent linked to it. So I have to use my power rule first. So in the numerator here, remember, you multiply the exponents. Also be careful that 3 is a 3 to the 1st. So if I multiply all the exponents inside parentheses, I get 3 to the 2nd and x to the 10th. So now I'm done. The parentheses are off. I still have the 27, x to the 3rd, and the denominator. Now I can multiply out the exponents. 3 squared is 9. And now I can use my quotient rule. So this mixed practice, you're going to use multiple rules. So you got to keep those straight. The 9 and the 27 both divide by 9. So I have 1 on top, 3 on bottom. X to the 10th divided by x to the 3rd is x to the 7th. So I could write this x to the 7th over 3. I could also write it 1/3 x to the 7th. Either way is fine. So again, it's the order that you do the rules is important. You cannot use the division rule first in this case because you have those parentheses with the power on the outside. So you got to do your order of operations and take care of that first. Same idea with 14 here. I need to use my power rule first here to get rid of the parentheses and simplify that. So keep in mind that 2 has an exponent of 1. Remember, your rule is that you take the 3 and multiply all the exponents times it. So that would be 2 to the 3rd, a to the 6th, and b to the 12th. Now I'm going to multiply out the 2 to the 3rd. That's going to be 8. And now I'm going to use my quotient rule. So 8 divided by 4 is 2. A to the 6th divided by a to the 3rd, subtract a to the 3rd. Subtract your exponents, you get a to the 3rd. B to the 12th divided by b to the 7th is b to the 5th. 15, again, you need to use your power rule first because we need to get rid of those parentheses and use the power rule. So my numerator is going to stay the same for right now. The denominator, remember your power rule, you got to take all these exponents, which they're all 1s, and multiply them by the 2 on the outside. So that would be 4 squared, which is 16, w to the 2nd, v to the 2nd. Now I'm going to use my quotient rule. The 12/16ths, remember, just reduce that like a fraction. They can both divide by 4. So I'm going to have 3 on top, 4 on bottom. W to the 9th divided by W to the 2nd is W to the 7th. b to the fourth divided by v to the second is v to the second. Subtract those exponents. You could also write it with the 3/4 out separately. Last one here, you need to use the power rule in the numerator and the denominator. Again, be careful. Remember, everything inside parentheses has an exponent, and those all are going to be multiplied by that 4. So the first one's going to be 2 to the 4th, which is 16, c to the 4th, and d to the 16th. So I took all those exponents inside parentheses times that 4. The bottom, again, every part in there has an exponent. So if I take all those exponents times 2, it's going to be 2 to the 2nd, which is 4, c to the 4th, and d to the 6th. Now I'm going to use my quotient rule. 16 divided by 4 is 4. C to the 4th divided by c to the 4th is c to the 0. And remember, those cancel out to 1. The number 1, and when you multiply with 1, it doesn't do anything. And then d to the 16th divided by d to the 6th, subtract your exponents, is d to the 10th. So with the mixed practice, be real careful. You need the order that you go in does matter. All right, now flip your paper over here. Now we got some bigger problems going on. So there's lots of different ways that you can approach these. The easiest thing, I think, to simplify is the easiest. So if you look at 17, yes, we're going to use the power rule because we have that 3, everything to the 3rd power. But instead of taking every exponent and multiplying it by 3 and then simplifying everything, I would simplify first. When you simplify, you get an equivalent expression. It's just simpler. So I would look at the inside here and see if I can simplify. So inside here, 2/4 reduces to 1/2. So you got the 1 on the top, the 2 on the bottom. M to the 4th divided by m to the 2nd. Subtract your exponents, you get m to the 2nd. N to the 2nd divided by n to the 1st. Subtract your exponents, you get n to the 1st. Now all that's going to be taken to the 3rd power. So I'm going to rewrite this because I don't need the 1 on top. You don't have to rewrite it. Just trying to make it a little easier here. Okay, now every exponent inside here needs to be taken times 3 because that's the power rule. So you're going to have m to the, 2 times 3 is m to the 6th, n to the 3rd. On the bottom, remember, you're going to take that exponent of 1 and multiply it by the 3. You're going to have 2 to the 3rd. Well, 2 to the 3rd is 8. So you have m to the 6th, n to the 3rd over 8. You could also write that with the 1/8 out front. Either way is fine. Now, if you had instead multiplied all of these exponents times 3 and then reduced, you should come up with the same answer. I just think it's easier to reduce first. So check out 19. Inside parentheses, you have that expression. I would see if there's anything that I can reduce. So the 4/5 cannot reduce. A divided by A is 1, so those cancel out. B to the 2nd divided by B to the 1st, subtract your exponents, you get a B. So that simplifies a little bit there. Now we need to use the power rule. Everything inside there has an exponent. Everything needs to be taken to the 2nd power. So you're going to take 2 times all those exponents. You're going to have 4 squared. 4 squared, b squared, and 5 squared. So 4 squared is 16, 5 squared is 25. You could also have that 6/25 on the outside. You can write it either way. Okay, let's go down here and look at 21. Now 21, if you take a look, you don't have any exponent, or you don't have any parentheses that have an exponent on the outside, so we don't have to use the power rule first. In the numerator, it's all multiplication. So remember, we're going to multiply the coefficients first. So 2 times 3 would give you 6. You have p to the 1st and p to the 2nd, which would give you p to the 3rd. Now this is our product rule. Remember, you add the exponents. And as we get bigger problems with more steps, you really got to keep the rules straight. You got q to the 1st and q to the 4th. Add your exponents. That's q to the 5th. Now we're going to use the quotient rule. So we're going to use the division rule. 6 divided by -6 gives you -1. P to the 3rd divided by p to the 1st. Remember, your quotient rule is subtract the exponents, is p to the 2nd. Q to the 5th divided by q to the 5th is q to the 0, and anything to the 0 power is 1. So probably the way you're going to see this is just with the negative on the outside. Because remember, the q's are going to cancel out. There's 5 on top, 5 on bottom. They're going to cancel out to 1. So here we multiplied these together first using the product rule, and then we used our quotient rule. All right, 23's got a lot going on here. You not only have multiplication on top, but you also have a power to a power. So you have these exponents you need to take care of first. So remember your power rule. Every exponent inside there is going to be multiplied by that exponent on the outside. So for this first one, 2 times 1 is going to give you 2 to the second, which is 4. 2 times 3 is going to give you x to the 6th. Over here, 3 times 1 is 3, so 3 to the 3rd is 27. 3 times 4 is 12, so that's going to be y to the 12th. Now, you got lots of options here. You could simplify right now. So the 4 and the 12, since one is in the numerator, one's in the denominator, you can reduce that. 4 and 12 divide by 4. And then I'm going to use my quotient rule here. Actually, first let's go back here. That 27 has 27 times 1 is 27. Let's put the coefficient up front. X to the 6th divided by x to the 4th. Subtract your exponents, you get x to the 2nd. Y to the 12th divided by y to the 5th. Subtract your exponents, you get y to the 7th. Now, I also have that 3 on bottom. And 27 divided by 3 is 9. Which I could have reduced that right here also. Okay? So the thing you get into as the problems get more involved is there's lots of different ways you can do them, but there are some things that have to be in a certain order. And if you have the parentheses with the power on the outside, you need to take care of that first. Okay, let's go hop over here and do 24, another one that's a little bit more involved. So again, inside parentheses, there's nothing I can simplify. So I need to take care of the power rule first. So I'm going to take every exponent inside parentheses times that 2 on the outside. So this is going to be 3 to the 2nd, which is 9, m to the 4th, times, now be careful here, this negative 4 is going to be to the 2nd power, because that's negative 4 is to the 1st power, and when you multiply it by the 2 on the outside, that's going to be negative 4 to the 2nd, and negative 4 times a negative 4 is a positive 16. N to the 5th to the 2nd is going to be n to the 10th. So we got rid of the parentheses, which is good. Now, several things you can do. You can look to see if you can simplify any of the coefficients now, which the 16 and the 8 reduce. You can divide them both by 8. So 9 times 2 is 18. M to the 4th, and you have an m to the 3rd in the bottom, so we're going to use the quotient rule. So you're going to subtract the exponents. 4 minus 3 would be m to the 1st. N to the 10th divided by n to the 4th, because they're in the different parts of the fraction. That's division. You're going to subtract your exponents. That's going to be n to the 6th. So you have 18m n to the 6th. All right, let's go down here to the bottom. 25 is a lot going on here. Okay, so it's basically everything we've done so far this week. So first thing, I can't subtract before I get this simplified. And I can only subtract, remember, if they're like monomials or like terms. So these are being multiplied together. So I'm going to use my product rule. First of all, the 8 and the negative 3 are just coefficients. Multiply those together. C to the 1st times C to the 4th. Add your exponents is C to the 5th. D to the 3rd. There's no other D's up there, so that's just going to stay the same. All right, now we need to reduce this expression on the left side here. So negative 24 divided by 6 is negative 4. C to the 5th divided by C to the 2nd is C to the 3rd. D to the 3rd divided by D to the 1st is D to the 2nd. Now I'm down to subtraction, and they are like monomials. They have the same variables to the same power, C to the 3rd, D to the 2nd. Now remember, when you add or subtract monomials, you only add or subtract the coefficients. So I'm going to add the opposite here. Negative 4 plus negative 9 is negative 13, and then the variables and the exponents stay the same. So you had your subtraction, you had your product rule, and you had your division rule. All right, now 27. 27, you have to do your exponents first here with the power rule. So take a look. I can't do anything with these parentheses up top until I take them to the third power. So that's going to come first. So 2 to the first, remember, I'm going to take all the exponents inside there times to the third power. So the 2, that's going to be 2 to the third, which is 8. M to the second to the third, multiply your exponent, is m to the sixth. Again, this 3 has an exponent of 1. I'm going to take both of those exponents inside there times the 3 on the outside. So you're going to get 3 to the third, which is 27. N to the fourth to the third, multiply your exponents, is n to the 12th. Now I can't subtract until I get everything simplified and see if I have like monomials. So let's simplify this expression on the left side. First of all, see if anything reduces. The 9 and the 27 can both be divided by 9. So 8 times 3 is 24. Now, m to the sixth and the m to the fourth is in the bottom of the fraction. So this is division, so you're going to use your quotient rule. M to the sixth divided by m to the fourth. Subtract your exponents is m to the second. N to the 12th divided by n to the 7th is n to the 5th. Now I'm down to subtraction. I can only subtract them if they are like monomial, like terms, which they are. So you only subtract the coefficients. 24 minus 18 is 6, m to the second, n to the 5th. Okay, so now what I want you to do is go back and try the evens we have left, and then check them, and I will post all the answers for those on Canvas, and you can fix them. So try those on your own.